Hello cave dwellers. In this box we have a system which sold over 5 million units during its lifetime. A system which fueled both gamers' imaginations and laid the foundation for a generation of coders to come. A system which we'll be reminiscing over in this series while applying a little TLC. This is the ZX Spectrum. Unlike our other refurbishment videos, cosmetics are not a problem here. This Spectrum has been in its box for 25 years and looks to be in pristine condition. A sticker indicates that this is the 48K model as opposed to the base 16K model. An original power supply is included, and we'll be considering the implications of using this and the associated dangers. And the Horizons tapes are included, programmed by Scion to help you get familiar with the system, and loaded by just about nobody. So that's what we're working with today. Let's begin by checking that power supply and finding out what the symptoms of the problem are so that we can attempt to repair. Our original power supply is rated at 9 volts DC, and we're going to take a look inside to see if there are any obvious problems or reasons why we shouldn't plug it in. First impressions are good, capacitors look fine, but when we turn the board over, there's a sight common to cheap 80s electronics. It's the dry solder joint. What we'll do then is patch this up and check the output on a multimeter. It's worth mentioning that this power supply is an unregulated power supply. Without a regulator to stabilise the output voltage, any change in input voltage will be reflected on the output voltage. In other words, if you don't have a clean electrical supply, those ripples of voltage could impact the behaviour of circuits and devices on the other side, or even damage them. We'll see later that there is a voltage regulator inside the ZX Spectrum, and this unregulated power supply was likely a step taken as a cost-cutting exercise, which certainly won't be the last example we find in the ZX Spectrum. The multimeter then is showing just under 15 volts, well over the 9 volts it says on the tin. Is this because it's faulty? Well no, it's because it's unregulated again. The label means it's guaranteed to give more than 9 volts when drawing 1.4 amps. And as it's not currently under load, it will show a slightly higher reading. Still well over the 9 volts though. So the question is, should we use this power supply? And in short, it would probably be fine, but why risk your sensitive vintage electronics when a regulated alternative can be picked up for £5 or £6? It's just not worth the risk. So we'll put that back in the box for decoration. Let's crack our specky open then, get familiar with what's inside and see what challenges are waiting for us. Keyboard connectors removed, we can now see inside the machine and discover that this is an issue 2 ZX Spectrum, the second of 8 revisions throughout the machine's 10-year lifespan. You'll have noticed already what a compact design this machine has. Designed by Richard Altwasser of Sinclair Research, it's based around a Zilog Z80 CPU running at 3.5 MHz, and the base model had 16 KB of RAM. We'll take a high-level tour around the board now, and we'll get to know some of these components more intimately as we're fault finding. Our power plugs in at the top right here then, where you'll also find an inductor coil used to produce those voltages needed other than the 5 volts. The large piece of metal is a heatsink for the voltage regulator located on its lower right, which is adjacent to the famous Spectrum speaker. You'll notice the soundtrack to this series does not feature Spectrum music because I didn't want to make your ears bleed. The rows of chips along the bottom are the RAM modules. The initial 16K is on the left hand side, and the additional 32KB can be found on the right hand side. Part numbers may be deceptive, however. In another cost-cutting exercise, Sir Clive Sinclair used 40 64KB chips with only one half of their capacity enabled, simply because he got them for a good price. The Spectrum's ROM chip lives at the top right hand corner here, and it contains an evolution of Sinclair Basic, originally developed in 1979 for the ZX80 and present in all Spectrum computers. It's the reason you could write rude programs on Spectrum screens before running out of British computer stores. The Spectrum CPU is a Zilog Z80, a design which dates back to 1976 and became one of the most popular and widely used CPUs in home computers in the 80s. It was designed to be binary compatible with the Intel 8080, while offering its own improvements, for example an enhanced instruction set and a better interrupt system. The transistor on top of this CPU is known as the Spider modification. It's a factory-fitted modification on the Model 2 Spectrums to help overcome problems caused by the ULA chip, which we'll come on to shortly. Moving along, we have the logic chips responsible for RAM address decoding and multiplexing, and in another cost-cutting exercise, these chips were replaced with a single ULA chip from the board Model 5 onwards. And then we have the infamous ZX Spectrum ULA or Uncommitted Logic Array chip. Its responsibilities are to deal with the tape and audio input-output, to read the keyboard and to generate the display. To ensure the display was kept up to date, the ULA was given the highest priority in reading RAM, specifically the memory mapped picture display area in the standard 16K of RAM that we saw at the bottom left hand corner of the board. The ULA wasn't without problems. For example, it had timing errors, and for a chip responsible for reading keyboard input, there were circumstances when 50% of the time it would fail to read the keys. These were addressed using what was known as the dead cockroach fix, a printed board connected to the ULA to stop the CPU and the TV interface from fighting over the data bus. And a further modification was required in the Model 2 board, like we have here, with the Spider fix. That's the transistor that sits on top of our Z80 CPU, and this acted as a gate to the CPU for the ULA's input-output requests, as it was discovered the chip was contending all input-output access on the system and not just its own. A series of bugs, patches and fixes, all of which should really have been integrated into a revised design of the chip, but in true Sinclair style, they plastered over the problem for as long as possible. For video output, the Spectrum creates a composite signal, which is then fed into the RF modulator, and we would tune our televisions into it, usually on channel 36. The television would convert the signal back into composite for display, and naturally that resulted in some loss of image quality. It also presents a problem on modern televisions, where aerial inputs are becoming less and less common. But thankfully a very simple modification exists which dates back as far as a 1986 Crash magazine, in which they described how to bypass the RF modulator and connect directly to the composite signal on the leg here before it feeds into the modulator. Expansion was achieved on the Spectrum with the double-sided 28-pin edge connector at the back of the machine. Third-party expansions such as the Kempston joystick interface allowed us to play games with a proper joystick as opposed to those fleshy rubbery keys. The multi-face add-on allowed us to dump the system's memory at any point, which was useful for saving your games, even more useful for creating unauthorized backups. And the ZX interface here, which allowed you to play the 16K ROM cartridges. If we look then at the underside of the board, where most of the soldering takes place, we have what it looks like a series of wrinkles. These wrinkles are actually blobs of tin, layered over the copper at the time of production with the solder mask on top. While it looks worrying, it's actually quite normal. And guess what? It was the cheap option when it came to manufacturing at the time. The Spectrum, as we've discovered, wasn't without bugs, but this is certainly one unique to my system. So that concludes our brief, high-level tour of our Issue 2 ZX Spectrum. Join me in part 2 when we explore why it's not working and hopefully get it back up and running again for a few games. Thanks for watching. Take care.